All right, here's a quick video on Lab 4 in our statistics class. I don't know that you really need this video, but I've got some feedback that students like them, so I figured I might as well make it just in case anybody wants to watch it. In this lab, like most of your labs, there's a tab that has all the instructions that kind of tells you everything that you need to do. I tried to make this as user-friendly as possible. The yellow instructions correspond with the yellow tab, orange tab, and red tab. And what you'll see as you work your way through this lab is that what we're going to end up doing is creating a confidence interval and doing hypothesis testing. So kind of the main two topics that we've been working on in our class, we're going to see how we can do those in Excel instead of using our calculator functions. So we'll start out with the population tab here. I've already done most of the work for you. So I randomly generated some numbers. You can completely ignore these. I used just that random formula that we used in the previous lab. And then I used a formula that you haven't seen yet. It's the log norm inverse function. So it's kind of like the norm inverse function, but it doesn't give you something that's normally distributed. It gives you something that kind of has this shape that you see down here. And I did that intentionally because I think that this shape might better model the salaries that different surgeons make. Most surgeons do pretty well, but you got this big tail going out to the right because there's some surgeons, I don't know, maybe they work for a professional sports team, or own their own practice, or have been around for 20 years or something. For some reason, they make lots of money. So you got this tail going out to the right. Anyways, we have all of these different observations here. There's 1,000 of them in red. And we're going to think about this as our population. Really, a population might have more than 1,000 observations. But I didn't want to make it so large that the size of this file was too big for you to upload. So I stopped it at 1,000. So these 1,000 observations here represent the salaries of all the surgeons in the population. So this surgeon right here made $128,000 last year. Must be nice. First thing I want you to do is calculate the population mean, the population standard deviation, and comment on the shape of the parent distribution, the shape of this population. Maybe my beautiful histogram here, whose bins are bounded by nice round numbers you might notice, is enough for you to figure out the shape of the population. I'm pretty sure I tell you which functions to use to calculate the mean and the standard deviation here on the instruction tab. But maybe more important than calculating these numbers is to think about the symbols that the population mean and the population standard deviation represent, because we're going to end up referencing these numbers later on in this lab. So again, not much for you to do on this tab. Essentially, you're just filling out these three boxes right here. Then you move over to the confidence interval tab. The idea with the confidence interval is you're making a guess for mu, the population average. Note that we have the population average. You're going to have written it right here, the population mean. But we're going to pretend we don't know that population mean, and we're going to use a random sample of surgeons, figure out their salaries, and then make a guess at the population mean based on that data. So what you need for this tab is some sample data. The way you're going to get the sample data is you're going to type in any 36 numbers you want between 1 and 1,000 in orange here. So I don't know, 49 for my 49ers, sure. My favorite baseball player growing up was Ricky Henderson. He wore 24, so I'll put in 24 here. My birthday is 8/29, so I'll put that in for my third. Whatever. Pick any numbers you want randomly between 1 and 1,000 and fill them out in orange here. And as you do that, what you'll see is automatically numbers in red get pulled up here. The numbers in red will be the salaries of 36 randomly selected surgeons. Now that we have this sample data here, we can create our confidence interval. What you'll see if you read through the instructions is the way that Excel creates confidence intervals is they tell you the margin of error. So as long as you know the point estimate and the margin of error, you can get the lower bound and the upper bound of the confidence interval. So think about what tells you the point estimate of your confidence interval. And then for the margin of error, you're going to use this function. I think it's confidence norm. And what you'll see is this confidence norm function needs alpha, and then sigma, the population standard deviation, and then n as its three arguments. Alpha, sigma, and n. I think those things will all be written up here. Let's see, here's alpha, here's sigma, here's n. I put little hints on the cells in blue. You can read through these. Maybe this will help you make sure that you put the correct numbers in each of these different places. So hopefully you can get the point estimate and the margin of error, and then from that you can get the lower bound and the upper bound of your confidence interval. And then what I want you to do is tell me what that tells you. And hint, what that tells you is information about mu, the population average, which we pretend we don't know, right? The population's so big that we're not able to calculate the average. That's kind of the story that we're pretending throughout this class. However, if you go over to this population tab, we actually could and do calculate the population mean right here. So for this gray box, you're pretending you don't know the population average, even though it's written right here in your workbook. And then we come down here and we're like, well, actually, we do know the population average, even though maybe it's not realistic that you would. So maybe you can see if that population average really does fall within the lower and upper bounds of your confidence interval. That's the end of the confidence interval tab. Then you can move over to the hypothesis testing tab. I talk about this in the instructions, but the short version of what we're doing in this tab is we're testing the claim that brain surgeons make more money than regular surgeons. So the way you're going to test this claim is you're going to randomly select 36 brain surgeons, and the way you're going to do that is you're going to type the numbers from 10 to 45 in pink here. So there's one brain surgeon, there's another, there's another, there's another. I'm going to create this data over here, which are the salaries of 36 randomly selected brain surgeons. And then I'm going to state my null and alternative hypotheses. Your null hypothesis is that mu equals mu naught, and your alternative hypothesis is mu is greater than mu naught, because our claim is that brain surgeons make more than regular surgeons. That's where the greater than comes from. You'll have to figure out what mu naught is equal to. Then the next step in our hypothesis testing is to state and justify the shape of the distribution, and then state the center and state the spread. So the relevant distribution here is not the parent distribution that we talk about in this tab here that has this right skewed shape. Maybe I shouldn't have told you that. It's instead talking about the shape of the sampling distribution. So maybe your answer won't be right skewed. Maybe it'll be something else, and maybe you can explain why it's something else in this box in blue here. Then figure out the center and the spread, and then calculate the p-value. And once you know the p-value, you're good. The reason you're good is because in the instructions, I tell you over here to test your claim with a 95% level of certainty. So maybe that tells you all you need to know about the p-value in order to make your conclusion. When you're making your conclusion here, make sure you state it the way we stated in our class. So there's 3 key things going on. First, why you're doing what you're doing. Is the p-value greater than alpha or less than alpha? Then what that means for the null hypothesis. Are you going to reject the null hypothesis, or is there not enough evidence to reject the null hypothesis? And then what that means in the context of this example. Brain surgeons do make more money than regular surgeons. There's not enough evidence to conclude that brain surgeons make more money than regular surgeons, that kind of stuff. Once you finish that, you're all done with the lab.